Welcome to the lecture on rational expressions, adding, subtracting, and complex fractions. We're going to start the lecture off today with talking about adding and subtracting rational expressions. Remember that a rational expression is just a polynomial divided by a polynomial, so we're going to be dealing with fractions. Remember that when you add or subtract fractions, you can't do that unless you have a common denominator. So that's going to be our biggest hurdle in these problems, trying to figure out what the least common denominator should be, rewriting each fraction so that it has that common denominator, and then adding or subtracting the numerators. So let's go ahead and start with a sample problem, and I'll talk through the steps here as we progress. So the first thing we're going to do when we look at our problem is factor each denominator completely. In this particular example, we have x plus 4 and x minus 7 in our denominator. Those are already factored. They're linear terms, so we can't really break them down any further. So we have step 1 done. Step 2, we want to find the lowest common denominator by writing each factor the greatest number of times that it appears in any given denominator. So if I have x plus 4 happening once in the first fraction, and x minus 7 happening once in the second fraction, then my lowest common denominator is going to need to be x plus 4 times x minus 7. So now what we're going to do in step 3 is change our two fractions so that they have this new LCD, this least common denominator. So I'm going to write two new fractions, each having this common denominator in the bottom. So x plus 4 times x minus 7 is my new denominator. So now I need to find out what the new numerators are going to be. That's step 4. So if I have x plus 4 to begin with, and I want to get to x plus 4 times x minus 7, I already have the x plus 4, so all I'm missing is the x minus 7. So we would need to multiply the bottom and the top by that missing factor. So in the numerator, the new top that I'm going to get, I have the original top of my fraction, 2x, times this new factor x minus 7 that I had to multiply by because I was missing it. Let's try that again with the second fraction. In the second fraction, I have x minus 7 in the denominator. I'm missing the x plus 4 factor. So we would need to multiply by it on the top and on the bottom to keep the fraction balanced. So I have my original numerator, which was 3x, times the missing factor. So here are my two new fractions. They have the right denominators, and we've had to change the numerators. Once we have our common denominator, we're ready to go ahead and add across the tops. So I'm going to make this into one single fraction with this common denominator, and I'm going to consolidate the two fractions by combining the two tops. While I'm at it here, I can go ahead and distribute that 2x across and also the 3x across. So 2x times x is 2x squared. 2x times minus 7 is minus 14x. Positive 3x times x is positive 3x squared, and positive 3x times 4 is positive 12x. Now we just want to simplify that new numerator. We've got a couple like terms on top. So 2x squared plus 3x squared is 5x squared. And negative 14x plus 12x is negative 2x. So now what we can do is see if this final fraction is reduced. If it's possible to factor the numerator, you probably should do that just to see if there's going to be any factors on top and bottom that might cancel out. So if I look at this numerator, at the very least there's a GCF since each term has an x. So I could factor out an x, and that would leave me with 5x minus 2 on top. Unfortunately, doing that GCF doesn't really give me any factors on top that are going to cancel on the bottom. So both of these would be correct answers. This one here or the factored form down here. Both are correct. Okay, so that's the process. We want to get a common denominator by factoring all of our denominators, and then we're going to create new fractions by multiplying by the missing factor or factors, and then we're going to simplify the top. So let's try that with this next example. Our denominators are x plus 3, x minus 3, and x squared minus 9. Now x plus 3 and x minus 3 can't factor any further, but x squared minus 9 does factor. It's a difference of squares. So it's going to factor into x minus 3 times x plus 3. So when we try to find our common denominator, notice that we need to have an x plus 3 factor since that shows up once in a couple fractions, and we also need an x minus 3 since that shows up once in a couple of our fractions. So our common denominator is going to be x minus 3 times x plus 3. We need both of those. So we're going to create 3 new fractions with this common denominator. And when we do this, we're going to create new numerators as well. So if we look at the first fraction, it already has the x plus 3. What it's missing is the x minus 3. So I would need to multiply by that on the top and the bottom to balance out the fraction. So the new numerator is going to be the original 4 that I had up there times that missing factor, x minus 3. In our second fraction, we already have the x minus 3 factor. What we're missing is the x plus 3 factor. So I would need to multiply by x plus 3 on the top and on the bottom. So I have my original x times the missing factor x plus 3. For the last fraction, we already had the x minus 3 and we already had the x plus 3. So I'm not missing any factors. So all I have on the top is the original numerator that we started with, 18. So now once we have our new numerators across the top, we can go ahead and consolidate all 3 fractions into one denominator, and in the top we're going to distribute all of these across and see what we end up with. So if I distribute my 4, I'm going to get 4x minus 12. When you distribute this x, be very careful. We need to take the negative with the x. So negative x times x is negative x squared, and negative x times 3 is negative 3x. And then we have a minus 18 on the end. So we've consolidated our 3 fractions into one, and now we just need to clean up the numerator. If I combine like terms on the top, we only have a negative x squared term by itself, and we have a 4x and a minus 3x, which is going to be a a plus x on top, and then we have a negative 12 and a negative 18, which is negative 30. And we're ready to be done. If we try to factor the top, it's not possible. We can't find 2 factors that are going to multiply and give us the right signs. So let's go ahead and put our box around our final solution. Okay, in our next example, we have the denominator 3x minus 21 and 49 minus x squared. Oops, I think I went too far, excuse me. So we have 5x over x plus 3 plus x plus 2 over x minus 6 over x squared plus 3x. So we have 3 denominators. X plus 3 and x are already as factored as they can get, but x squared plus 3x does factor further because there's a GCF. So if I pull out my x, I'm going to have an x plus 3 left over. So my common denominator needs to have one x because I have x showing up once in a couple of fractions, and I need an x plus 3 as well. So my common denominator is going to be x times x plus 3. So let's rewrite our 3 fractions so that they have this new denominator. So in the first fraction, I already have the x plus 3. What I'm missing is the x. So we would need to multiply this times x on the bottom and times x on the top. What's 5x times x? That's going to be 5x squared. So that's our new numerator. For the second fraction, we already have the x. We're missing the x plus 3. So we're going to have to multiply by x plus 3 across the top. Now, I probably wouldn't recommend trying to do all of this in your head. Just go ahead and write x plus 2 in parentheses times x plus 3 in parentheses, and in the next step you can FOIL that out and figure out what you get. For the last fraction, we already have the x in the denominator and the x plus 3, so we're not missing anything, so our numerator is going to stay 6. Now that we have our common denominator, let's go ahead and consolidate our three fractions. So the first numerator is 5x squared. And for the second fraction, here's where we're going to do that FOILing. And if we FOIL this out, we're going to get an x squared. The middle term will be a 2x plus a 3x, so that's going to be a 5x. And 2 times 3 is 6. And then our last fraction has a minus 6 on top. So combining like terms, notice that the 6's are going to cancel out, and that leaves us with 5x squared plus x squared, which is 6x squared, plus 5x. Now this numerator does factor because both of these terms on top share an x in common. So if I factor out x like a GCF, that would leave me with 6x plus 5. And we want to do that because the x on top can now cancel with the x on the bottom. So our reduced or simplified fraction is 6x plus 5 over x plus 3. And there's our final solution. On the next example, we have 5t plus 3 over 2 minus t plus 1 minus 5t over t minus 2. If you look at these two denominators, they look almost identical, but they have opposite signs. So they're opposites of each other. So when you talk about a common denominator, we're not going to need to require the common denominator to have the factor 2 minus t and the factor t minus 2, because those really are the same factor, they just have different signs. So how are we going to make these denominators be the same? The easiest way to do that is to switch one of them around and counterbalance with a negative. What I typically like to do if I have an addition problem like this is I might change the second denominator to 2 minus t, and because I'm changing the order and changing it to its opposite, I have to counterbalance that by changing this plus to a minus. If this original symbol in between had been a minus to begin with, then it would have changed to a plus. So we're just taking the opposite sign of this fraction to counterbalance the fact that we're taking the opposite sign in the denominator. So now my two denominators are exactly the same, so I don't even have to get a common denominator. I already have one. It's 2 minus t. So if I consolidate these two fractions, the numerator on top for the first fraction is 5t plus 3. The numerator on the second one is 1 minus 5t, and here's where you need to be careful. We want to subtract these two numerators, but we want to subtract the entire second numerator from the entire first numerator. So you need to use parentheses here, especially around that second numerator, because now we're going to have to distribute that negative across. The first set of parentheses aren't as necessary because there's nothing in front that we would have to distribute. So I can drop the first parentheses and just get 5t plus 3, and when I distribute my negative across the second set of parentheses, I'll get minus 1 plus 5t all over our 2 minus t. Now combining like terms, 5t plus 5t is 10t, plus 3 minus 1 is positive 2. And just to check here, the numerator does factor. 2 goes into both 2 and 10, so we could factor out a 2, and that would leave us with 5t plus 1. However, nothing in the top cancels with any factor in the bottom, so we can't really reduce this any further. So your answer is just this factored form, or it would also be correct to leave your answer in this expanded form. Okay, our next example. We have the denominator 3x minus 21 and the denominator 49 minus x squared. So in both of these denominators, they can be factored. The first one, you need to notice that 3 goes into 21. So I can factor out a 3, and that will leave me with x minus 7. The second denominator is a difference of squares, since 49 is a perfect square. So if we factor this, because the 49 comes first, we need to start our factors off with 7s. Since the x comes second, we need to have the x's come second in our factors. One of these should be plus, and one of these should be minus. So to look at our denominators and try to figure out what a common denominator should be, you have a couple of choices here. Notice that I have a 3 showing up in this first denominator, and that doesn't show up in our second denominator at all. So in our common denominator, we're going to need to have at least that 3 showing up. Another thing that we need to have is an x minus 7, or if you look over here, we also have a 7 minus x. Those are opposites again, just like in the last example. So if we can change the order around of one of them and counterbalance with a negative, then those two factors will be the same. It doesn't really matter which one you decide to switch. If you decided to switch the first one and change it to 7 minus x, then you could counterbalance that opposite by putting a negative up in the top. If you decided to change the second one instead and changed it to x minus 7, then you could change this plus to a minus. So you can do it either way. You just want to do it once, though. You don't want to do it both ways. So let's say that I stick with what I have written over here. Let's say that I switch x minus 7 to 7 minus x, so I counterbalance and throw a negative in the top so that now I'm not changing the original fraction at all. It's still equivalent to what I had before. So in terms of my common denominator, we're going to want to use this 7 minus x since it's showing up in each of my fractions. And I also need a 7 plus x since that showed up in the denominator of my second fraction. So my common denominator is 3 times 7 minus x times 7 plus x. So let's change our two fractions so that they have this new common denominator. So the first fraction had the 3 and it had the 7 minus x. It's missing the 7 plus x. So we would need to multiply this one by 7 plus x in the bottom and 7 plus x in the top. Remember that negative that we put in there to counterbalance switching the order. So that's still there. So we're going to have a negative 2 and then that 7 plus x. For the second fraction, we already have the 7 plus x. We already have the 7 minus x. The only thing we're missing is the 3. So we would have to multiply the top and the bottom by 3, which makes this new numerator x times 3, or 3x. So now we have our new fractions. Let's consolidate them into a single fraction with one denominator. And then we're going to go ahead and distribute our negative 2 across. So we'll get negative 14 minus 2x plus our 3x. Negative 2x plus 3x is positive 1x, and that doesn't factor any further, so our final solution looks like this. Okay, on our next example, we have x squared plus 2xy plus y squared in our denominator, and x squared minus y squared in our second denominator. Both of these can factor. The first one is a trinomial, so we're going to use reverse FOIL, set up our two sets of parentheses. I need an x and an x to multiply to x squared. I need a y and a y to multiply to y squared. And in order to get a 2xy in the middle, I just need to make these both pluses. So I'll get an xy plus an xy is our 2xy. For the second denominator, we have a square minus a square. So this is a difference of squares pattern. So we need an x and an x, a y and a y, but one of them is plus and one of them is minus. Now our common denominator, our least common denominator, this one you need to be a little bit careful about. We have x plus y showing up in our first denominator and in our second denominator. So we definitely need an x plus y, but we need the x plus y factor to occur the greatest number of times that it occurs in any denominator. In this first denominator, when you have x plus y times x plus y, that's like x plus y squared. So we have to have x plus y occurring twice at the very least, because it occurs twice in this first denominator. So in our common denominator, we're going to need x plus y quantity squared. We need 2 of those factors. We also need an x minus y, because that occurs once in our second fraction. So our common denominator needs 2 factors of x plus y and 1 factor of x minus y. So in our new fractions, we're going to rewrite these with our new common denominator. And if we look at our first fraction, we already have the 2x plus y's. We're missing the x minus y. So we would need to multiply by x minus y on the top and on the bottom. So the new numerator is going to be x times parentheses x minus y. For the second fraction, we have 1 x plus y and 1 x minus y. We're missing the other x plus y, because remember, we need 2 of those. So I have to multiply by that on the top and on the bottom. So my new numerator is y times x plus y. I want to reiterate here that I discourage you from trying to distribute that right away in your head. Use parentheses like I have here. If you try to distribute it in your head, what I often will see is students forget that you actually need to distribute the negative with the y. And so students will get the wrong signs on terms and things won't combine properly. So take the extra time and take the extra step to wait and distribute in your next line of work. So let's do that next line. We're going to consolidate our 2 fractions into 1. And here's where we're going to do that distributing. So x times x is x squared. X times minus y is minus xy. Negative y times x is negative xy. I'm just switching the order around to make it consistent. And then negative y times y is negative y squared. We have a couple like terms there. Oops. So if I combine them, I'm going to have x squared minus 2xy minus y squared, all over x plus y quantity squared times x minus y. Now the top, it's very tempting to factor that using reverse FOIL. If you tried, it's almost going to work. You could try x and x, y and y, and make them both negative. That will get you a minus 2xy in the middle. The problem with this is negative y times negative y is positive y squared, and we need a negative y squared. So this doesn't actually factor correctly. And if you try to change your signs around, you'll see that nothing will make this work. So this doesn't factor in the numerator, so we just have to leave our answer like that. Okay, so that's adding and subtracting rational expressions. You want to get a common denominator. Change your fractions so that they have that new common denominator in the new numerators, and then you add or subtract the tops and just try to simplify your final answer. The next thing that we're going to focus on is how to simplify complex fractions. Now, complex fractions are fractions within fractions. And you can see from this example, they look pretty messy. So the method that we're going to use here is kind of similar to what we were just doing. We're going to look at all of our denominators in the top and in the bottom, and we're going to try to find out what the least common denominator should be. Once we find out what that least common denominator is, we're going to multiply the top by that and the bottom by that, and that should cancel out all of our denominators and give us a more simplified fraction. And then we're just going to clean it up and make sure that it's reduced. So, for example, if we look at this problem, our denominators are y minus 1, y minus 1, and y. So what should the common denominator be? Well, we need a y, and we need a y minus 1. What we're going to do is take that common denominator, and we're going to multiply the top by it and the bottom by it. You have to do it to both so that we're multiplying by a fancy version of 1 right here, so that we're not changing the original problem, we're keeping it balanced. Now by multiplying by the common denominator, let's see what happens. We're going to get a new fraction. When I take this first fraction times my common denominator, this y in the bottom cancels out this y in my common denominator, so what we're going to have left is y plus 3, wrap it in parentheses, times the y minus 1 that I have over here. Okay, let's try that again with our second term. So our common denominator was y times y minus 1, so now we're going to take this fraction times all of that. The y minus 1 in the denominator cancels the y minus 1 in our common denominator, and all we have left is the 4 and the y. And remember, there's a minus in front of that 4. So this is our new numerator. Notice we got rid of the denominators that we had on top. Now we're going to do that same thing in the bottom. So if I take this fraction times our common denominator, the y minus 1 cancels with the y minus 1, and I have this y on top times this y over here, and that's y squared. Now if I take the second fraction right here times my common denominator, the y in the bottom cancels with this y over here, and all we have left is 1 times y minus 1, so that's just going to be y minus 1. And there's a plus in front of that. So all the denominators are now gone from the top and from the bottom. All we have to do now is simplify the numerator and just make sure that our answer is reduced. So if we FOIL out the top here, we're going to get a y squared, we're going to get a 3y and a minus y, which reduces to a plus 2y, and plus 3 times minus 1 is negative 3. And I'm going to bring down my minus 4y. So all I did there was FOIL. And now we just want to combine some like terms here on top. We're going to get y squared. 2y minus 4y is negative 2y. And then we have that minus 3. And if you want to try to factor the top, we have a trinomial. So we're going to need a y and a y. 3 times 1 is 3. If I make the 3 minus and the 1 plus, then I'll get a negative 2 on top. So the top does factor. If you try to factor the bottom, it doesn't work because we would have to have y times y and 1 times 1, and we would need one of these to be plus and one of these to be minus to get our negative 1, but that would make the middle term go away, and we have a middle term of plus 1. So the denominator is prime. It doesn't factor. So you're just going to have to leave it as y squared plus y minus 1. So since the bottom doesn't factor, nothing's going to cancel on the top and the bottom. So our final reduced answer is just this. Okay, let's try that again. On our next example, excuse me, we have x plus 1 and x minus 1 and x plus 1 and x minus 1 for all of our denominators. So what does the common denominator have to be? It needs to be an x plus 1 and an x minus 1. So we're going to multiply by that common denominator on the top and on the bottom. So if I take this first fraction times that common denominator, the x plus 1 in the denominator cancels with this x plus 1 over here, so all we have left is the x minus 1 on top times the x minus 1 from the common denominator. Okay, then we have our minus. If we go to our second fraction over here, And we do the same thing. This time the x minus 1 cancels, and we have x plus 1 times x plus 1. No more fractions in our denominator. On the bottom, we're going to do the same thing. So if we take x minus 1 over x plus 1 times our common denominator, these x plus 1 factors will cancel out, and we have x minus 1 times x minus 1 again. So it looks just like the top. But then we have a plus sign in between, and now when we multiply this fraction across, the x minus 1s are going to cancel, and we have x plus 1 times x plus 1. So the numerator and the denominator of our new fraction look almost identical. It's just that middle sign in between is different. Okay, so now we have to clean this all up. So in the numerator, if we FOIL out the top here, we're going to get x squared. The middle term is going to be minus 2x, and the last term is going to be a plus 1. On the next factor over here, if we FOIL this out, we're going to get an x squared plus a 2x plus 1. Now be careful, there was a minus in front of all that. So I'm going to keep all this in parentheses because I haven't yet distributed that negative across. We'll have to do that in the next step. In the denominator, we're going to get the same two expressions, but this time we're going to get a plus in between. So when I FOIL out this denominator, I'm going to get x squared minus 2x plus 1 plus x squared plus 2x plus 1. Now let's simplify. If I distribute my negative across, we're going to get that x squared minus 2x plus 1 from over here. And when I distribute, I get minus x squared minus 2x minus 1. In the denominator, let me just recopy what we have so far. And in our next step, we're going to combine all of our like terms. So in the numerator, look what happens. The x squareds cancel out, the 1s cancel out, and we just end up with negative 4x on top. In the denominator, we have an x squared plus an x squared, so that's 2x squared. Our minus 2x and plus 2x cancel out, and plus 1 is plus 2. We're almost there. This final fraction isn't quite reduced because the denominator does factor. So if I factor out a GCF of 2 from the denominator, and I'm left with x squared plus 1, that 2 that we factored out will cancel into the 4, leaving me with 2 left over on top. So our final answer is going to be negative 2x on top over x squared plus 1. Okay? These are long problems. They take quite a few steps, but you just need to be organized and make sure you write every step out carefully. Now we're going to try 2 more of these complex fractions, but what makes the next 2 examples sort of similar is that they are things involving negative exponents. So before you use the methods that we just talked about, you need to deal with your negative exponents first and remember how to rewrite this correctly. On this first example, we have negative exponents, and you probably know that negative exponents is like a reciprocal. It flips you around. So if you have a negative exponent in the top, it flips to the bottom. If you have a negative exponent in the bottom, it would flip to the top. One mistake that I see commonly is to take this original fraction, and students will often rewrite it as x minus y, so flipping these top 2 to the bottom, and then flipping these bottom 2 up to the top and writing x squared minus y squared. That is incorrect. Okay? It would be correct if we had multiplication in between our negative exponent terms. If I have multiplication in between, then I can flip both of these x squareds and y squareds to the top and the x to the first and y to the first to the bottom. But when there's subtraction or addition in between your terms, you're not allowed to do that. So what we have to do instead is be a little bit more careful, and we're going to need to flip each term individually because each term is separated by that subtraction. So how would you flip x to the negative 1? Well, it would become 1 over x. How would you flip y to the negative 1? It would become 1 over y. And then that minus, or that subtraction that was in between, stays put. So notice how we're getting two individual fractions. In the denominator, we're going to do the same thing. X to the negative 2 becomes 1 over x squared, minus y to the negative 2 becomes 1 over y squared. So what makes this problem more difficult is the fact that these negative exponents actually cause us to have a complex fraction. So once you rewrite the original problem this way, now we're going to simplify this by using the methods we just talked about. In our denominator, we have an x, a y, an x squared, and a y squared. So our common denominator needs to have as many x's as any individual fraction has. So if I have 1 here but 2 here, I need to have at least 2 in my common denominator. And the same goes for y's. So my common denominator must have x squared and y squared. What we're going to do is multiply by that common denominator on the top and on the bottom. So if I take this first fraction and I multiply it across to x squared y squared, one of these x's cancels with one of these x's, so what I have left is an x y squared times 1. So that's just xy squared. Okay, if I go to the next fraction and take this times my common denominator, the y on the bottom cancels with one of the y's on top, so what I have left is an x squared y times 1, so that would be x squared y. And there was a minus in between. In the denominator, I have 1 over x squared. When I multiply that times my x squared y squared, the x squareds cancel out completely, so all I have left is y squared times 1, or y squared. And for my second fraction, we're going to take 1 over y squared, multiply that across, and the y squared cancels out completely, leaving me with x squared times 1, which is just x squared. And there's a minus in between. So here's our new simplified fraction so far. Simplified in that we no longer have a complex fraction. But it's not completely simplified because we can definitely factor the numerator and the denominator, and there's a potential for some of those factors to cancel each other out. So if you look at the numerator, they both have x's and y's. The least x that I have is x to the first. The least y that I have is y to the first. So my GCF is x to the first, y to the first, or just xy. If I factor that out, then from this first term, I'm going to have 1y left over. From the second term, I'm going to have excuse me, 1x left over, with a minus in between. In the denominator, we have y squared minus x squared. That's a difference of squares. Since the y comes first, we need to write it first in our factors. X's come second. 1 is plus, 1 is minus. So the y minus x factors cancel each other out, and we're left with xy over y plus x. And there's our simplified answer. Okay, let's try one more like that with our negative exponents. So again, these are separated by additions, so you need to treat each individual negative exponent as its own little fraction. Okay, don't try to flip the entire denominator and the entire numerator. You have to do it term by term. So a to the negative 1 will flip over to 1 over a. Then we have our plus. Be careful on this next one. We have 2a to the negative 2. Since there are no parentheses around the 2, only the a is a negative exponent, so only the a gets flipped. So the 2 stays on top, and the a squared goes to the denominator. The same holds for our 2a to the minus 1. Only the a is raised to the negative 1, so only the a to the first goes to the bottom. The 2 will stay on top. And then for our last one over here, there are parentheses, so both the 2 and the a flip to the denominator, and we have a 1 on top. So here's our new complex fraction. If we look for our common denominator, we have an a and an a squared, an a and a 2a. So what do we need to have in our common denominator? Well, let's talk about our a's first. The most a's that any fraction has is an a squared. So my common denominator has to have an a squared as well. I also have a 2 showing up in my denominator, so I have to have a 2 showing up in my common denominator. So it looks like our common denominator will be 2a squared. So we're going to multiply by that on the top and on the bottom. So if we take 1 over a times 2a squared, the a in the denominator cancels with one of the a's here, so we're left with 2a times 1, so just 2a. In our next fraction, we're going to take 2 over a squared times our common denominator. This time the a squareds cancel out completely, and we're left with this 2 times this 2, and there's a plus sign in front, so that's going to be plus 4. On the bottom left, we're going to take 2a times 2a squared. 1a in the bottom cancels with 1a on my common denominator, so I'm left with 2a here times 2, that's going to be 4a. And for my last fraction, we're going to take 1 over 2a times 2a squared. The 2 cancels, one of the a's cancels, so I have 1a left times 1, so a times 1 is a. So here's what we have so far. Now if you look at that denominator, 4a plus a, those are like terms. 4a plus a is just 5a. And the top, if you wanted to, you could factor out a 2, and that would leave you with a plus 2. Unfortunately, the 2 and the 5 aren't going to cancel out, so this is our reduced fraction. Okay, we're up to our last example. It's a little bit different kind of problem. It uses something called a difference quotient. And this is something you're going to hear quite a bit about, especially if you go on into higher levels of mathematics. A difference quotient is using a function and evaluating the expression f of a plus h minus f of a all over h. And in this case, we're going to use the function 4 over x. So to evaluate our difference quotient, we're going to basically start with this as a formula. This is our formula for what a difference quotient is. Okay, so we just need to apply this to our particular function. So let's talk about how you figure out what f of a plus h is. Well, the function f says f of whatever your input is should be 4 over that input. So if I have x, then I'm going to have 4 over x. If this was y, then it would be 4 over y. If it was 7, then it would be 4 over 7, for example. So in the expression f of a plus h, my expression, my input, is a plus h, so my function should take 4 over that a plus h. So this f of a plus h turns into 4 over a plus h. So it's exactly the same as our original function, but we substituted this input in for x. Okay, now we need to figure out what f of a is. So all we're going to do is substitute in a inside that box. So f of a, if I change this to an a, the function becomes 4 over a. So we're just substituting in a where that x is. So this is going to give me 4 over a. So f of a plus h was 4 over a plus h. F of a was 4 over a, and we want all of that divided by h. So this is a little bit strange looking at first if you haven't talked a lot about functions, but the purpose of this example is to get us to this complex fraction. Once we've evaluated those functions, expressions up here, and gotten this expression, now we need to simplify. And to do that, we're going to use the same process we've just talked about with complex fractions. We're going to look at all of our denominators. Now the denominators I have on the top are a plus h and a. I don't have any denominators in the bottom because this h is like h over 1. So for my common denominator, I just need these two denominators multiplied together. So when we simplify complex fractions, we write down our common denominator, which was the a times the a plus h, and we multiply by that on the top and also on the bottom. So if we do that, for this first fraction, when I multiply 4 over a plus h times that common denominator, the a plus h factor cancels out, and we're left with this 4 times that a, so we have 4a. Then we're going to have our minus sign, and now we're going to take our second fraction, 4 over a, and when we multiply that across, the a in the denominator cancels with this a, so we're left with our 4 times parentheses a plus h. So all these denominators down here disappear. Now in the denominator, because there is no denominator here, there was just a 1, nothing cancels out. So in your denominator, you're going to have this h left over and both the a and the a plus h left over. Don't distribute there. I would recommend just recopying all those terms next to each other, and don't distribute because you'll see in a few moments we will get some cancellation happening. So leave it in this factored form. So now we have a new fraction that's not complex anymore, and we just need to clean it up a little bit. So in the numerator, I can do some distributing, distribute my negative and my 4 across. So I have this 4a, and then minus 4 times a is minus 4a, and minus 4 times h is minus 4h. I'm going to leave the denominator as is right now. Don't distribute downstairs because you want to be able to cancel some things later on. So if you look at that numerator, now that we've distributed, we can see that these two 4a terms are going to cancel out. We're left with negative 4h over h, a, parentheses a plus h. And here is where that cancellation is going to happen. If you've done these problems correctly, this will always happen. You will get a factor of h on top that will cancel with the h on the bottom. So our simplified answer becomes negative 4 on top over a parentheses a plus h. And there is our final answer. Okay, so that's called a difference quotient. It uses functions, but once you've used this function, you end up with a complex fraction that we simplify by multiplying by our common denominator on top and bottom, simplifying and reducing as we go. Alright, that concludes our lecture notes on rational expressions, adding, subtracting, and complex fractions. Good luck.